All right, class, welcome to Unit 5, Lesson 2. And because of my limited time that I have in the classroom to do these videos, I'm going to start kind of skipping around in the notes a little more. I'm not going to be doing every single problem because I know a lot of you aren't even able to print the notes to work through them all with me. So I am going to do these examples and then I'm going to leave the you tries, except I might do the more difficult ones at the bottom of each section, okay? So that our video lessons will be a little bit shorter, but I won't be providing all of the answers for every practice assignment or you try problem, okay? But I still do encourage you to try them. And I know that you all have a million websites that you can type these into and check your own answers. All those apps that you use to help you out, I'm going to phrase it that way while you're doing your homework, okay? You can use those to help you out here as well. So let's talk about what today's lesson is about. It is, the last lesson was all adding and subtracting polynomials. Today is going to be multiplying, so multiplying polynomials. And I'm just going to call it polys for short, okay? To multiply a monomial, remember monomial means one, by a polynomial, which means many, we will need to distribute the monomial into the polynomial. And so I do need you to refer back to our Unit 4 when we did all of those exponent rules, and we will be using the product rule when we do this. Remember that if you have the base that's the same, x times x, then we need to add the exponents. So let's jump right in with example 1. I'm doing x times x, and I still have my base of x, but these exponents here are 1 and 1, so I need to add them together. All right? Next, I'm going to do x times 4, which, if you recall, gives us just 4x. And the exponent will stay a 1 because there was only one x when I multiplied. Let's look at example 2. I am going to multiply the coefficients. So I've got that right here off to the left-hand side under you try. We're going to multiply the coefficients, add the exponents, and keep the same base, just like we did with our exponent rules. So I'm going to do all of my coefficients first, okay? 5 times 3 is 15. 5 times negative 1 is negative 5. 5 times negative 7 is negative 35. Now I'm ready to do the variables, okay, and then adding the exponents. So m cubed times m squared, that's m to the 5th power. M cubed times m to the 1st is m to the 4th. And then m cubed times no other m's is just going to stay m cubed. So those are my first two examples. All right. 7 and 8 are some of the more difficult ones. But let's see, I'm going to actually jump down here and I'm going to do example number 9 for you. Okay. Example number 9, the reason I'm going to do it is because it deals with two different bases. So I'm going to start with the p's, okay? P squared times p to the 5th gives me p to the 7th power. P squared times negative p to the 1st gives me negative p cubed. Now I'm going to move over and do my q's. So Q3 and Q2 is Q3 plus 2 is 5. Q3 times Q to the 1st is Q to the 4th power. And that is my final answer. Just like what we were doing with our exponent rules, okay? So I do encourage you to try some of these examples if you want to pause the video and again use those tools that you utilize to check your work at home when you do practice assignments. In number 15 here and 16, I'm going to step it up a little bit. So we are not only going to need to distribute the monomial in, we will then need to simplify. So this is going to be a two-parter, okay? So I'm going to start with distributing first. -2 times 3 is -6. X times x is x squared. Then I have -2 times -4 gives me a +8, and x just comes down because there's no x to multiply it by in that second term. So remember, multiply the coefficients and add any exponents when the bases are the same. Now I am going to bring down this plus 7x, and now I can see that I will need to simplify by combining like terms, and I know that I need to combine them because there's this plus sign that separates the terms. So that tells me combine like terms. 8x plus 17x is going to change and give me a positive 15x. And that is now my final answer. Great job. Number 16 is even more complex. All right, so I'm going to need to distribute now twice into both sets of parentheses. So 5 and -7 is -35 w squared. 5 times 3 is 15, and bring down that w. -2 times 13 is going to be -26, bring the w down. -2 times -9 will be a +18, and I have w to the first and w squared, so it's going to give me w cubed. And now I am ready to combine any like terms and also to write this in descending order. So 18w cubed is the highest degree exponent, so that goes first. Next, I have -35w squared, and that will just come down. And then finally, I do have to combine 15w minus 26w, and that's going to give me a -11w. And that will be my final answer. Let's look at some geometric applications. We need to find the area of this trapezoid. Okay, so first I need to remember the formula for the area of a trapezoid, and that is 1/2 times the sum of the bases times the height. So let's plug all of these in. So I know I'm going to have 1/2. Then I'm going to need to add the bases. So, and that's going to be inside parentheses. 2x cubed minus x, and then it's plus, because I'm adding, that's a part of the formula, 8x squared plus 3x. Close my parentheses, and I'm going to times that all by the height, which is 4x squared. So let's start by simplifying inside the parentheses. So I have 2x cubed and and 8x squared. So those can't be combined. So let's take a second look at that. Okay. So 2x cubed stays. And then I have, let's see, an 8x squared, nothing to combine that with, so it stays. And I do see, let me switch a color here. 3x and minus 1x is plus 2x. All right. Now I can multiply, let me just jot this down, the 1/2 from right here and the 4x squares from that side. And if I do that, remember just to draw that line all the way across. And so I have 1 times 4 is 4 divided by 2. 4 divided by 2 is just 2x squared. Okay, so I am going to multiply that trinomial just by 2x squared. So let me erase all this little scratch work. 2x squared is now in the front. And so now I have 2 times 2 is 4, x squared and x cubed, add those together. 2 times 8 is a positive 16, x squared and x squared, I have 4 of them. And then finally 2 times 2 is 4, x squared times x to the first is x cubed. All right, and that is how I can find the area of a trapezoid if I have polynomials that are larger than a monomial, meaning one term, okay? Now let's try to find the area of the shaded region as a simplified expression. Number 18. So for a problem like this, if you were in class with me, what I would do is I would hold up a piece of paper, okay? And my piece of paper would represent this entire rectangle. And then I would physically cut with scissors out a section from the center somewhere of the paper. And I would ask you, how would you find the area of the paper that was left after I cut out this piece? And so we would eventually get to where you would tell me that I would need to subtract, okay? So that is exactly what I'm going to do. I'm going to find the area of the large rectangle, and I'm going to find the area of the small rectangle, and then I'm going to subtract them. So let's do that. The area of the larger triangle would be these numbers on the outside. So 6x times 8x minus 1. And then the area of the inside rectangle would be this. 2x times 5x plus 3. And why am I multiplying those together? Forgive me. I'm sure that you remember, but the area of a rectangle is length times width. So I'm multiplying them together, but I always want to try to put my monomial in front. Okay? And then don't forget, we will be subtracting them. So now I'm ready to distribute here. 6 times 8 is 48. X times x is x squared. 6x times negative 1 is negative 6x. Now let's distribute the negative 2x. Negative 2 times 5 is negative 10. X times x is x squared. Negative 2 times 3 is negative 6. X times nothing is just x. And now, just like we did up above, I'm going to need to combine my like terms in my last step. So 48x squared minus 10x squared is 38x squares. Negative 6x is negative 12x. And that is our final answer. All right, so that is how to multiply a monomial, one term, by a polynomial, which could be two or more terms. Let's take a look at how we're going to do this if we are multiplying very specifically two binomials. Remember, binomials have two terms. X plus 2 is two terms. X plus 4 is two terms. Now, I teach this two different ways. You will hear a lot of teachers say use FOIL, first, outer, inner, last. It is all just really, it's distributive property with polynomials. However, people have come up with this acronym FOIL, and it only will work specifically when you have binomials. So I will show it to you, but most of my students end up really liking this area model better because it will work for anything that you're multiplying together. Any size polynomials that need to be multiplied, the area model will always work. FOIL only works with binomials, okay? So let me show you the area model first, and then I'm going to show you FOIL, and I'm going to let you practice with these and see which method you like best. When it comes to your assignments, you can use either method. I am okay with both. They're both acceptable. All right, so let's do the area model first. So what I do with this area model is I take my first binomial, and it does not matter if you want to write it down the side or across the top, but take each term and separate it, okay, so that it's in front of a box. Then you're going to take your second binomial and you're going to put it on the other side. So x plus 4. So one goes on top, one goes on the left, and they can go either way. Now what we're going to do is we're going to multiply. So I have x times x, and that gives me x squared. Next, I will do x times 4 and get 4x. Now I'm ready to do the 2. So I'm going to do 2, and then at the top of that box is an x, so it's 2x. And then 2 times 4 will be this very last empty box. 2 times 4 is 8. And so once you have gotten the area model filled in, you will just combine any like terms that you have. So 4x plus 2x is 6x. And now I'm going to write this in descending order. So I have x squared, I have 6x after I combined, and that's positive, and I have a positive 8. And that is my final answer using the area model. Okay? Let's take a look at how FOIL method works. Now, unfortunately, I only have these 4 colors to use on my smartboard. I would have preferred to use a different color other than black, simply because black is the color of the problem, but there's no way for me to use a 4th color here, okay? So first would be the first term from the first binomial and the first term from the second binomial. So the first times the first is going to be 2 times 1 is 2, x times x is x squared. Next, I'm going to do the outer 2 terms. So this is the outside and the outside. If you look at them as terms 1, 2, 3, 4, you do the 2 that are on the outside. So 2x times 5, I'm sorry, times negative 5 is negative 10x. Next, I'm going to do the inside terms. So that's on the inside and that's on the inside. So 1 times x is a positive 1x. And now I'm going to do the last two terms. That's the last term in the first binomial. That's the last term in the second binomial. So 1 times -5 is -5. So that is where I get first, outer, whoops, I should have used green, outer, inner, and then last, the last terms. And that is why people call this the FOIL method, because those letters spell the word FOIL. Okay? Now you're not done once you've done that part. You still have to combine any like terms that you see. So -10x plus 1x is -9x. And then you would bring down the other terms. All right, so you can refer to it as FOIL if you want to, but it is really just utilizing the distributive property to binomials. All right, so I have shown you how to use each method, and I would like for you to really do try to practice some of these right here, okay? Now I want to talk about number 5 here. Number 5, I have x plus 4 squared. And I'm going to write this out to the side here. X plus 4 squared. And here's what students try to do. They try to just say, okay, that's x squared and that's 4 squared, which is 16. And they think that that's it. They're done. That is not the proper way to do this. I know that when we had our exponent rules, when we were learning them, we did like something like this. It was 4x squared, and then we would distribute and get 16. And then x, the 1 times 2 would get me x squared. This is okay. The only reason this is okay is because this is a monomial. This is a monomial, and that's why that power rule works. But that power rule does not apply when you have two terms. This is a binomial. So please, with a binomial, do not ever try to distribute the exponent like that, okay? So I do want to show you the proper way to do it. Here's what we need to do. If I gave you 3 squared and I told you to explain to me what that meant, you would say, well, that's 3 times 3. And I do it 2 times because the exponent is a 2, right? So there's 2 times. That same ideal is what we need to use for example number 5 here. So I have parentheses and I've got that stuff inside there, and I need to copy that stuff 2 times. Okay, so what was inside there now? Well, it's an x plus 4 and it's an x plus 4. And now I'm ready to either do FOIL method or fill in my box method. So let me do the box method another time. So I've got x plus 4 on top, and I've got x plus 4 down the left. And now I'm going to do my multiplying. So I've got x times x is x squared. X times 4 is 4x. 4 times x, if I'm going to do this box, 4 times x is 4x. And then, of course, 4 times 4 is 16. And now once I simplify everything, I have an x squared. I have 4x and 4x, which is 8x. And I have a 16. This is my final answer. And I want you to notice how these are not the same. All right, this is actually missing the inside piece, the 8x. So that is why we cannot use that distributive property here, the power rule. We have to still write it out twice and use our box method. I sometimes also call the area model a box method, okay, because you're creating boxes. So again, be sure to get some more practice with that using these other examples that are here. So let me erase all this scratch work that I did so that you can really see the problems that you can practice. Okay, so go ahead, pause the video and try those and just check those with those online websites that you guys use. And now this is exactly the reason why I prefer the area model to FOIL. Okay, FOIL does not work when you have a binomial, that's two terms, times a trinomial, which is three terms, because you no longer have, you do have some outers, the x and the minus 6, and you do have inners, 4 and x squared, but you don't have the other pieces, okay? So let's finish writing this down. So we're going to stick to the area model for anything that's bigger than 2 by 2. So how did I decide how to draw this area model out? Because I already did them for you. All I did was I saw that the first one had 2, so I needed 1 and 2 boxes to go down that way. And then this has 3, so I needed 1, 2, 3 across that way. Some people ask me, can I do it the other way? Could I do 2 across and 3 down? And the answer to that is absolutely yes. You would just need to switch up where you put your terms. At this point, my binomial would have to go on top, and then my trinomial would have to go down the side. So you're allowed to do it that way as well, okay? I just do it out horizontally so that I make the best use of the space in my guided notes. All right? So actually, I'm going to erase that one and just make a note. You can make your box this way too. Okay. All right. So don't feel like you're stuck to certain measurements. You can do 2 by 3 or 3 by 2. It doesn't really matter. Okay. So now I'm going to go ahead and fill in this box method. So it does get a little messy. I've got x times x squared, which is x cubed. And then I've got x times x cubed. I'm sorry, x times 3x. It's going to give me 3x squared. And then I've got x down here on the side times this negative 6. So it's negative 6x. Let's move to the bottom. I now have this 4 here, and I want to multiply it by the x squared on the top. So 4x squared. On the bottom, again, I have a 4, and I want to multiply that by 3x at the top of the box. 4 times 3 is 12. Keep the x. And finally, I've got 4 times negative 6, and that's negative 24. And something interesting happens here when you have larger polynomials that you're multiplying together. You'll notice that you've got like terms here. That is going to give me, if I add them, 4 plus 3 is 7x squared. And then I have another set of like terms. I have 12x minus 6x, which is a positive 6x. And then I just need to still remember to bring over x cubed, and that was a positive 7, and bring over this minus 24. And again, I wrote this in standard form, just like we learned in yesterday's notes. Standard form means that the exponents are in order from greatest to least. All right, let's look at a geometric application of this. And again, I encourage you to try any of these practice assignments here, okay? Those 3 problems, 10, 11, and 12. So this geometric application is going to work exactly the same way that this one did over here, where I explained how I would show you a piece of paper and then cut out a rectangle in the middle. And in order to find the area that was left in the shaded region, we would have to subtract. We're going to do the exact same process. So the area of the large minus the area of the small. So let's go ahead and write this down. My large is out here, so I have 2x plus 7 times 9x minus 2. So that is the large rectangle. And I will subtract the small one. Okay, so 3x is the monomial, I want to put that first, times x plus 12. So I am going to need to multiply all of these together. I'm going to use this as an opportunity, since I have limited space here, to show you one more time the FOIL method, okay? So I'm going to have first term times first term, 2x and 9x is 18x squared. Now I'm going to do the outside terms. 2x times negative 2 is negative 4x. Now I'm going to do the inside terms. 7 times 9x is going to give me a positive 63x. 7 times negative 2, those are my last terms, the last term in each binomial. It's going to give me a negative 14. Okay, so that was the distributive property method, FOIL. Now let's go ahead and simplify the small rectangle. Negative 3x times x is negative 3x squared. Negative 3x times positive 12 is negative 36x. And now I am ready to go combine all the like terms that I have here. So 18x squared minus 3x squared is 15x squared. And then negative 4x plus 63x is 59x. 59 minus 36, when I combine all of those, is going to give me a positive 23x. And then the only thing not underlined here is this minus 14, so it's just going to come down at the back. And that is a geometric application for multiplying polynomials together. All right. There is a practice assignment posted onto Google Classroom for you. Go ahead, give that a try. Remember, reach out to myself, reach out to your classmates on Google Classroom, and we're going to get through this. Until next time.